Okay, guys, so let's go over the solutions to homework number 3, starting with exercise 1. So because these ones deal with quite a bit of arithmetic, I'm actually gonna um, pull out the calculator and show you how it's done manually rather than leaving you with just the number and wondering how we got there. So starting with exercise 1a, we can do 3 divided by 10. We'll do 0.3, but we'd actually store that as 0 because we're dealing with integers, okay? Next one is 11 divided by, sorry, modulus 4. That one is 3. Next one is 15 divided by 2.0, 7.5. Now, this one we can actually store as 7.5 because we are subtracting by a double, okay? So the result is going to get stored as a double, which is the larger of the data types, essentially. For 1D, we would do 4 modulus 5 plus 3, that gets us 7. E, we can do 3 times 7 modulus 4, 1. And then lastly, 7 modulus 4 times 3. Okay, that gets us 9. Let's look at the results there, and there you go. So that matches. Okay. So moving on, we have exercise 2. How are the operands and operators in the following expression associated? So we would do -4 times I, okay? And then we would do 6 modulus 4. We'd have two results, and then you would subtract this side from this side. Now, bearing in mind, you do have the incrementation here, but because it's after the I, you deal with that after. So it's not really relevant at this point. I'll show you what I mean with this example. What value will be assigned in part to the variable x if the variable I has a value of -2? So in here, we can do -4 times 2, okay? That would give us 8. Now, instead of incrementing I to 3, we use the original value because the incrementation is only being done afterwards, okay? So at this stage, it's not really relevant. If we were to use I later on in a further line in the program, then it would be relevant. But for now, it's not really something that we're dealing with. So if for example, the plus plus was before the I, then you would increment immediately. So we have 8 at least on one side. We've determined this side. We can do 6 modulus 4 gets us 2. So 8 minus 2, and we get 6. Let's check that out. And there you go. Value 6 will be assigned. And here are the parentheses, exactly as we were discussing. So you do this side first. You can do this side, get this answer. And then you subtract both. Okay? Okay. Now let's look at these expressions and calculate them to true or false. So the first one here, we have x minus 10 and x equal to or larger than or higher than -1. So this one, they both have to be true because we're using the AND operator for the expression to end up as true. So because x is 7, this bit is true, and it is larger than -1, so that's also true. So this one would be true. On the following one, we have not x, so this actually would this exclamation mark would actually do the opposite. So if we put 7 in there, it would give us true. But because you have the exclamation mark behind it, it would actually do the opposite and give us false. And right away, you can stop looking at the rest of the statement because we're using the AND operator. So if one side is false, then the rest doesn't really matter, right? We look at C, and for this one, we have x plus plus is equal to 8, okay? Or x is equal to 7. Now this one is false because in the first bit you would do so you would look at 7, right? Because the plus plus is after the x, we're dealing with the original value for now, okay? So we'd be looking at, okay, so is 7 equal to 8? That would give us false. So we know this side is false, but we still continue looking at the rest because we're looking at the OR operator. Now, another thing, when we get to this side, because we've incremented, x is now 8. So this would also be false. Therefore, we have true, false, false. And we can now look at exercise number 4. So this one can be a bit tricky because we have to go through it and try to understand the output and why we're getting a certain output. So let me take you to the development environment. Okay, so here we are. We start out with cout and then bool alpha. That just basically turns the zeros and ones to true and false, just so it's a bit more visually appealing. I guess it's a bit easier that way. Let's see. So we start by defining this Boolean res and an integer 5, okay, as y. So in this first bit, let's see if we can determine the result of this this statement, okay, this evaluation. So we start out with 7, that will be true. And then we have the OR operator. So this would be true right away, okay? This actually would give us false, but the interesting thing here is that because we're using the OR operator, as soon as it gets it true, it doesn't care about the rest. So this assignment, and just to make this clear, this is not checking if y is equal to 0. This is actually assigning 0 to y because it's only one equal sign rather than 2. But because it's already got a true here, it doesn't really care about the rest, and it's going to skip it altogether. So when we actually check the result of res here, that's going to be false. Actually, sorry, that's going to be true. But when we check, because we've got the true from the 7, but when we check the value of y, if you just look at this right away, you might think that it's going to be 0, but it's actually going to be 5, because when we're dealing with the OR operator, as soon as we get a true, it doesn't care about the rest. It's just the compiler just cares about being efficient and being fast. So it's gonna skip that altogether. Then we define 3 integers and we set them all to 0. Okay? So A, B, C. So in this line here, in this statement, we are using the OR operator, okay? And we are incrementing A to 1. So right away, we increment A to 1. And you might think that we are also incrementing B and C. But once you realize that we have the OR operator, once we get a 1 here, that equals true. And because that's true, this rest gets ignored. So B is still going to be 0, C is going to be 0, and that's what you're going to see printed out. So then we go ahead and we reset those again to 0. And now we're running a different evaluation. Now we're saying increment A and increment B. So either this side is going to be true, or this side is going to be true once we increment C, okay? And once we get to this point, it's going to do both, okay? Because it has to check if these two are true, right? So this is going to go to 1, that's going to be true. This is going to go to 1, it's going to be true. And when it gets to this bit, it's not going to care about this, because once we have true on the left side of the OR operator, because that's all it needs, it's going to ignore the rest. So this is going to be true, and then A is going to be 1, B is going to be 1, but C, because of that, C got ignored, unfortunately, that's going to be 0. So it's just something to bear in mind when you're dealing with OR operators. As soon as you get a true, it doesn't care about the rest. If you're dealing with an AND operator, as soon as it gets a false, it's not going to care about the rest. Okay, so let's run it and see what we get. And there you go, exactly as we expected. As I was telling you, we have this one's true because of the 7. Then the value of y, you might have missed it and thought this was going to be 0, but it's actually going to stay as 5. And then this first rest here, that's this one, okay? That's gonna be a true because this a gets incremented to a 1, and that's gonna equal true. Then only the a will get set to 1. The b and the c will get ignored in this line because of the OR operator. And then the same for the following line, except now b is also getting incremented. So I hope that helped in terms of understanding this bit. You can always just, it might be a bit too much to take in at first. So just break it up and do this first bit first, and then do the second one, and then the third one. And by the end of it, hopefully you should get it.